So we are heading to the first part of chapter 4, which is time value of money and single cash flows. We're gonna be doing some calculations, and I'm gonna show you this the shot of the BA2 Plus professional calculator. This is the one that we're gonna be using. I'm gonna be working on examples with that calculator, and this calculator should be the one that helps us find the answers to our problems. So every time we have a problem, I'm gonna pull the calculator up and use it. Now, first things first. I will strongly encourage you to go to second function and format and hit 9 and then enter. By doing that, the calculator is going to display all the decimals, all the decimals. So please do that as soon as you have a chance so that you can get all the decimals. Now, we mentioned time value of money in chapter 1, and we're going to be talking a little bit more explicitly about time value of money, right? This is the basic tool for making decisions about investing, right? Obviously, it can also be used in personal finance, right? It's the decisions that you make in order to know how to allocate the money that you have, right? Uh, we mentioned before, right? A dollar today is worth more than a dollar next year, right? So we make our decision based on the size of our cash flow, timing, and rate of return, right? How much money am I going to be receiving? How long does it going to take for me to receive that money? How much return am I going to be receiving for that money? And this diagram at the bottom of the presentation is very true. Money today is worth more than money next year, right? Therefore, we need to make more next year in order to compensate for that difference. So the first thing we're going to be doing is organizing our cash flows, right? Knowing how much money is it coming in, how much is it going out. We will always have outflows and inflows, right? It's not necessarily that we're making or we're losing money, but it's money that's coming into our pockets or money that's coming out of our pockets. In a financial calculator or in Excel, if money is coming out of our pockets, we're going to be using a negative sign. If money is coming into our pockets, we're going to be using a positive sign. That's the main difference, right? Money coming out is negative, money coming in it's positive, right? So we can be receiving or making payments monthly, quarterly, semi-annually, annually, different different time periods, right? Different time periods. So as we were mentioning, right? Inflow is the money that comes in, outflow is the money that goes out. So now, money coming in is not necessarily that we're making money. Money going out is not necessarily that we are losing money, right? We think of a loan, for example, if we think of a mortgage, well, we're going to have a lot of money coming in at the beginning, right? Then we're going to have smaller pieces yet consistent, and for a very, very, very long time of money going out, right? So that's one of the things. So we can organize our cash flows in what we call a timeline, right? Which is something like this, right? Uh, every time we use a timeline, we will start at year 0, which is today. Today is year 0, right? And from year 0, we move into the future 1, 2, or as many years as we have in mind, right? We're always going to have an interest rate. In this case, we have 5%, right? We know how much money is coming out, how much is going in, right? The one that's coming out has a negative sign because it's money that's going out of our pockets. Coming in positive, money going into our pockets. In this case, we invested $100 today. We earned 5% in 1 year, and at the end of the year, we got $105. So, yes, this is basically that example, right? $105 from your bank, it's the actual $100 that you deposit at the beginning plus a 5% return, right? So this is a formula that we use in order to calculate future value. Future value in 1 year, it's equal to present value, that is whatever we have today, times 1 plus the interest rate. Uh, Again, we this is kind of like the same thing. I mean, if we factorize 100 from this term, this becomes 1 plus the interest rate, which is what we have right here, right? $100 that we're investing plus 5% out of those $100 makes it 105. Now, we were only talking about one period, but in reality, we can leave our money sitting there for more than one period, right? And what's going to happen is we're going to be compounding our money. And by compounding, we mean we are going to be earning interest on interest, right? So in our previous example, we earned $5, right? So we went from $100 in year 0 to $105 in year 1. Now, if we move from year 1 to year 2, and if we're still making 5%, we're not going to make 5% out of $100. We're going to be making 5% out of $105. We've earned those $5, and those $5 are going to be earning money for us, right? So that's the rationale behind the modification on the formula. N is the number of years in which we're going to be investing. The power here, it's going to make this interest rate go up. We're going to be compounding. We're going to be earning interest on interest. Basically, this is how we do it, right? We earn 5% on the first year, 5% on the second year. It's 110.25. Now, if you remember, in the first year we earned $5. Now, the second year we're earning $5.25. I mean, 25 cents is not that much, right? Well, as time goes on, that component will become larger and larger and larger and more relevant. Now, let me show you with our calculator how to make this operation, right? So if you see the keys on the third row, these are the time value of money keys. These are the keys that we're going to be using to work our problems. First thing that we always do, we click second function and clear time value of money. The calculator stores information, and if we don't clear time value of money, there might be something there that will affect our calculation. So first step, always second function, clear time value of money. Now, N is the number of periods. In this case, we're investing for 2 years, right? So we hit 2 and then we hit enter. Sorry, not enter, N. Yes, I was thinking of other function. N. There you go. We know it's in because the equal sign shows up and this little triangle on top, right? So N. Now, 5% is the interest rate. We are just going to hit 5. The calculator already knows it's a percentage. You don't need to change it to decimal. This is a very important thing. If you're using the formula, you need to keep it as a decimal. You're using the calculator, you put it as a percentage, which is 5. Now, present value is $100, and I'm going to make it negative. Why negative? We are investing money. This is money that is coming out of our pockets. Therefore, since it's money that's coming out of our pockets, it needs to have a negative sign, right? PMT0, we haven't worked with this right now. You can skip it if you want to. I always like to put 0 just in case anything is being stored in the calculator. And now we have 4 out of the 5. If we have 4 out of the 5 variables, we can compute CPT upper left hand corner and then FV. And there you go, 110.25, which is this same number right here, right? Every time you use the calculator, I encourage you to write the value of the variables, right? These values right here so that it is easier for you to put it in here, right? So future value is $110.25. Now, this is a very interesting table, right? We were talking about $100 making 5% every year. So if we think of the interest we make in principal, the interest that we make on the original deposit is always going to be $500. $5, right? $5 every year. We're going to be making $5 every year. So it's $5 the first year, 10 the second year, and so forth. We can see this blue line right here. It grows very steady, right? So it's a very clean upward sloping line. Now the green line is the interest that we earn on interest. Now this we can barely see it. That's a 25 cents. The component starts growing, and suddenly it grows exponentially. Right? As time goes on, if we leave that thing sitting there for 40 years, we can see that the green component is way more than the other two components combined, right? That is the power of compounding.